Imagine handing a friend a check at a loud party. They have it in their hand, but it isn't really money yet. First, the bank has to look at it. Then a few other people in the room have to agree the check is real and that you didn't already hand the same one to someone else. Only after enough trusted folks nod and write it into the party's shared notebook does your friend relax and call it theirs. Until then, the check is in a kind of limbo, looking done but not truly settled. That gap between sent and actually final is exactly how a Bitcoin transaction moves. You can't just send money on the internet like an email. If Alice tries to move 0.1 BTC to Bob, how does the network stop her from spending it twice? And why does Bob sometimes wait 3 days for that money to feel real? Bitcoin is a public ledger called the blockchain, not a bank. It's a chain of blocks. Each block is a text file that lists transactions approved by the network. No central ledger exists. Instead, thousands of anonymous nodes store identical copies and race to add the next block every 10 minutes. The ledger is append only. Once a block is buried under 6 more, the transaction is final. The transaction is born. Alice broadcasts a message. I, Alice, assign 0.1 BTC to Bob's public address 1A1Z. She signs it with her private key. The signature proves she owns the coins without revealing the key. The raw transaction is 250 bytes of hex. Mempool limbo. The message lands in the mempool, a global waiting room. Miners collect thousands of these raw transactions, each with a fee in satoshis per byte. Typical fee today, 15 sat/v byte. Alice paid 30 sat/v byte, so her transaction floats near the top. Mining lottery. Miners race to solve SHA-256 double hashes of a block header. The header includes a nonce, the Merkle root of all transactions in the block, the previous block hash, and a target difficulty. At current difficulty, 25T, the winning nonce appears once every 10 minutes on average. The first to find it yells, bingo, and broadcasts the block. Block propagation. The new block zips across the network at 1 MB/s. Nodes validated. Check signatures. Ensure no double spends. Confirm Coinbase reward is correct. 6.25 BTC today plus fees. Invalid blocks get ignored. Valid ones get appended to the chain. Confirmation math. Each new block is one confirmation. A transaction is considered settled after 6 confirmations, is almost equal to 1 hour. Why 6? Because the probability of a chain reorg longer than 6 blocks is below 0.1%. Wallet update. Bob's wallet listens for blocks containing his address. When it sees the transaction in block 712,345, it marks the 0.1 BTC as spendable. The wallet doesn't trust any single node. It waits until 6 nodes agree on the same block height. Fee market reality. If Alice's fee is too low, her transaction sits in the mempool for days. In May 2023, the average confirmation time for sub-10 sat/v byte transactions hit 3.2 days. Miners prioritize high-fee transactions first. On April 20th, 2024, Alice sends 0.1 BTC, $6,000, to Bob at 1942 Universal Time Coordinated. She pays 25 sat/v byte. The transaction ID is 5C2AD4E9. It enters the mempool. At 19:48 a.m., miner in Reykjavik finds a nonce that produces a hash starting with 18 zeros. The block, height 836,124, contains Alice's transaction and 2,438 others. The block propagates to 12,000 nodes in 12 seconds. Bob's wallet sees it at height 836,124. After 6 more blocks, is almost equal to 60 minutes. Bob's wallet marks the coin spendable. Total latency, 62 minutes. Misconception: Bitcoin transactions are instant. Correction: they're instant to the network's eyes once mined, but finality requires 6 confirmations. The network can't know if a longer chain will appear, so apps wait. Bitcoin moves when miners solve a cryptographic puzzle, not when you click send. The 10-minute block time and 6 confirmation rule make double spends astronomically expensive, turning math into money. Like that check at the party, it only counts once enough of the room has signed off on it. Subscribe to Tech with Joel to see how the plumbing behind AI models, satellites, and even your coffee app actually works. How many confirmations do you wait for when you move crypto? Comment below. Subscribe to Tech with Joel. Subscribe to Tech with Joel.